Have you ever felt, completely overwhelmed by technical jargon, only to find out the concept itself is actually crucial, but maybe overlooked? It's like knowing your car has an engine, but never really thinking about what keeps it from overheating, right? Today, we're taking a deep dive into something called grounding. It might sound a bit technical, but honestly, for anyone who plugs anything into a wall, it's electricity's ultimate unseen safety net.
Exactly. Yeah, and to really get a handle on it, let's maybe start with a simple image. Picture a city's drainage system during a massive rainstorm. If those drains get clogged, what happens? Water has nowhere to go. It backs up, floods the streets, causes, well, huge problems.
Right.
Or even simpler, think about that tiny overflow hole you sometimes see in your sink. You might not notice it often, but it's absolutely crucial, right, if your main drain gets blocked. That little hole is what prevents a huge, messy overflow all over your bathroom floor. It's basically an escape route.
Okay, let's unpack this. That analogy, it really brings it to life. So, in the world of electricity, grounding plays an incredibly similar vital role. Our mission today is to sort of demystify this concept, understand precisely why it's so essential for your safety and, for keeping your electronics alive longer. And then, crucially, show you exactly where it's already working hard in your life, often without you even realizing it. We're breaking this down for everyone.
And at its core, it all goes back to a fundamental principle of electricity. Current always wants to flow from a higher electrical potential to a lower one. Always. So what's the absolute lowest potential point for electricity? Its ultimate destination. That would be the Earth itself, the ground, which we consider to be effectively 0 volts. It's the ultimate pathway for any runaway electricity, just like water always flows downhill to the lowest point.
That fundamental principle makes so much sense. Okay, so if electricity always seeks the lowest point, what happens when it's, stuck? When it's looking for that path, and the only path available is, let's say, through you. I mean, we all plug things into outlets without a second thought, but imagine for a moment that hidden danger, that silent predator lurking in your everyday appliances, just waiting for the right moment to strike. What exactly is it waiting for?
Well, that's precisely where things get incredibly dangerous. Let's use a very common household example, your washing machine.
All right.
Imagine the insulation around one of its internal wires gets damaged, maybe just from wear and tear over time. Now, the metal casing of the washing machine itself gets charged with electricity. It's essentially holding on to that electrical potential, like water building up behind a dam, just waiting for an opening, The problem arises when someone touches that charged appliance. What happens then? The current suddenly finds a path through the person's hand, then their body, down their leg, and finally into the ground. Now, when current flows through an abnormal path like that, not its intended circuit, we call it leakage in Korea. And when that current flows through the human body, that's what we define as electric shock.
Oh, right. The shock itself.
And it's incredibly dangerous, far more than most people probably realize. Even a tiny current, like 30 milliamperes, that's just 103 amperes, can be life-threatening.
30 milliamps. Wow,
Yeah,
that's incredibly small. Barely enough to flicker a tiny light bulb, yet it's lethal.
Mm.
So it's not really about the sheer amount of electricity necessarily, but the path it takes through your body that makes it so dangerous. That picture of a dangerous leaking current is unsettling. How does this grounding system, which sounds almost too simple, step in to actually prevent that nightmare scenario?
You've hit on the core of it, yeah. This is where protection grounding, SWIAT, comes to the rescue. Its function is remarkably elegant in its simplicity. We connect the metal casing of an electrical device directly to the earth using a dedicated wire, a ground wire. Now, if abnormal voltage or a fault current occurs, if that washing machine casing gets charged, like in our example, the electricity has a choice. It can try to flow through a person touching it, or it can flow through this dedicated grounding wire.
Oh, okay.
And the grounding wire is specifically designed to offer a much easier, much lower resistance path straight to that 0-volt earth. So the current preferentially flows through this wire, pretty much completely bypassing the person who touches the device. This significantly reduces the current flowing through anyone who touches it, preventing a serious shock. It's just like that sink overflow hole we talked about. If the main drain clogs, the water goes through the overflow instead of all of your floor. The ground wire is the ultimate emergency spillway for electricity.
That's brilliant. It's so simple when you put it like that. So what does this all mean for you at home? Let's bring this knowledge directly into our living rooms, our kitchens. Where can listeners actually see this safety system at work protecting them right now?
Okay, well, you'll see these at your wall outlets, your A. If you look closely inside the larger holes, you'll often notice small metal pieces or clips on the sides. These are the grounding terminals, the Dejos Psi. When you plug something in, especially a plug with those metal strips on the side, those strips connect with these terminals. And inside the building's wiring, these terminals connect to a dedicated wire that ultimately goes straight into the earth.
I see.
So if leakage current checkout appears on a device's metal casing, it safely travels through the power cord's ground wire, into the plug's metal strips, through the outlet's grounding terminals, then through the building's green grounding wire, and finally safely dissipated into the ground. It's a complete, safe escape circuit.
That makes sense.
And here's a practical tip, something that often goes overlooked. The elasticity of these grounding terminals, both on the plugs and inside the outlets, can weaken over time, just from repeated plugging and unplugging. This can make the connection less effective, less secure. So for your electrical safety, it's really important that these are repaired or replaced if they feel loose or aren't making good, firm contact. Think of it like a loose seatbelt. It might still click, but it won't protect you properly. A loose ground connection can lead to problems.
That's a really great tip, actually, because it means we should maybe occasionally just check those outlets, feel the plug going in, make sure it's snug. But grounding isn't just about preventing those big, scary shocks, right? You mentioned it does other things, too. It's not just a one-trick pony, so to speak.
That's absolutely right. It plays several other vital roles. For example, it protects sensitive electronic equipment from certain types of electrical noise or stray currents, which significantly helps prolong their lifespan. It also increases the reliability of complex electrical wiring systems, makes them more stable, less prone to weird glitches. And this next one might surprise you. It also helps immensely with electronic interference and electromagnetic waves.
Interference? How so?
Well, have you ever felt a slight tingle when touching a computer case, maybe? Or perhaps another electronic device like a metal laptop, especially when it's plugged in?
Oh, yeah, definitely. I felt that. Always wondered what it was.
That sensation is often due to very small leakage currents, you check in. While sometimes it's just an annoying feeling, these currents can also, over time, subtly damage precise electronic components inside the device. Grounding helps to safely channel away these small currents too, protecting your valuable devices from that unseen, sort of subtle cumulative damage.
That's fascinating. So it's not just preventing a major shock, but also stopping those little electrical burps that can wear down our expensive gadgets. You know, thinking about it, proper grounding could significantly reduce the digital noise that causes seemingly random errors, glitches, maybe even slowdowns in our most sensitive electronics, turning unpredictable performance into something much more reliable. So if I have, say, a high-end gaming PC or run a home music studio, is grounding even more critical for me than for someone just using a toaster?
Oh, absolutely, yes.
Yes.
The more sensitive your equipment, the more critical, robust grounding becomes. It truly creates a cleaner, more stable electrical environment for those devices to operate in. And, if we connect this to the bigger picture, you might be wondering, what does grounding actually look like in a building's infrastructure? Where is it?
Yeah. Where are these magic green wires hiding?
Well, you might not see them every day unless you're looking inside things. But if you peek inside your home's main electrical panel, the car or maybe the larger switchboards in an office building, you'll commonly see green wires, or sometimes green with a yellow stripe. They're usually connected to a metal bar. Green is the generally accepted standard color code for grounding wires in many parts of the world.
Yeah.
And these green wires, they all ultimately lead downwards, usually through conduits heading straight to the earth. They connect to a grounding plate ego, or a grounding road ego, which is literally buried deep in the soil beneath or near the building.
Wow, so it really does go right into the ground.
Directly into the earth. And it's fascinating how the quality of that connection, which we measure as grounding resistance or a chi, can actually vary. It depends a lot on the soil conditions, whether it's wet, dry, sandy, rocky, things like that. To ensure the best protection and performance, sometimes electricians need to actively lower this resistance. This might involve using special compounds called grounding resistance reducers, AD placed around the rod or plate, or maybe by burying the grounding plates or rods deeper into the earth, or even burying more of them to create a larger contact area. It's all about making that emergency pathway to the earth as clear and direct as low resistance as possible.
Okay, so from a simple analogy of a drain pipe all the way to this complex web of green wires buried up in the earth, we've really seen how grounding acts as this invisible guardian, hasn't it? Silently working behind the scenes to protect us and our electronics. It's such an elegant solution, really, to a critical problem. Something that initially seemed quite technical, but it's really all about fundamental safety and reliable performance for pretty much everything we plug in every day.
It truly is. And this perhaps raises an important question for you to think about. What other fundamental unseen principles are at play in our everyday technology? Things we might completely take for granted. And how might understanding them empower us, to be more informed, safer, and maybe even more appreciative of the innovations that surround us in this modern world?
That's a great thought to end on. We really encourage you, next time you plug something in, just take a moment, observe the plugs, look at the outlets in your home with a new appreciation, because now you know a bit more about what's really keeping you safe, silently, constantly, working away in the background.